So since we have learned about what is perceptron and the pictorial representation of the perceptron and how the output of a neural net has to be yesterday. So today we see that to achieve that accuracy of accuracy means proper classification. If any misclassification happens, again we need to update the weights because we haven't achieved that value one. So we have to update the weights. That weight updation can happen with the two methods. One is perceptron training rule, or you can have delta rule. Okay. So here, the precise learning problem is to determine a weight vector that causes the perceptron to produce the correct one, means either 1 or -1 output for each of the given training examples. Right? So we just use perceptron training rule, and based on that we'll solve a particular problem today. So one way to learn is, see here how the weight updation happens. So here the process is repeated. The weight updation process repeats through the training examples as many times as needed until the perceptron classifies all the training examples correctly. Right? So if any misclassification happens, the weights are to be modified at each step according to the perceptron training rule. So which will revise the weights associated with each input. Right? So before you apply your input, the input has to be multiplied with the weight. So the combination of weights and inputs have been produced to the network. So here we need to calculate the linear combinations of weights and inputs together, and activation function is going to be applied like we have discussed earlier yesterday. Just look at how the weights are going to be updated. If you think Wi is your original weight, Wi is your original weight, the updation of the weight will be the same weight along with delta W. So then what is this delta W? This delta Wi is nothing but your learning rate into eta. Here the symbol, n kind of symbol, you could see that, right? This is nothing but learning rate. At which speed, at what speed your system is learning, is getting trained. That's what I can say, is getting trained. That is called a learning rate of neural network. And we have two outputs here. The exact output is O, that is what you are getting. The target output is, which is given in the question. Means I'll be having some idea about in classification problems, what could be my target output, right? What could be my target classification? So the target output, it will be given to you, and the respective input is xi, right? So T is the target output, O is the actual output. Let us see a question here. So I have given three input matrices, x1, x2, x3. Remember, when a matrix has been given, actually we know that we have to multiply the weights and inputs, right? Here the inputs are x. So weights also has to be a matrix. See, I'm not giving a single input, right? Because I have been, I don't know how many input neurons are there. Suppose my input neurons are 1, 2, 3, 4. 4 neurons. My weight also has to be 4 weights. Because x1 into w1, x2 into w2, x3 into w3, and then x4 into w4, right? So this is the linear combination that we have discussed yesterday. So I have three different inputs. 3 times I'm going to make the system to get learned. So first I will apply x1 inputs, later I will apply x2, after that I will apply x3. So if you have 3 inputs, you should get 3 target outputs, means desired output. That is the fixed output. So I have T1, T2, T3 given to you. So learning rate is always the constant one. If you want, you can change with respect to the training examples. If you want to increase the speed, you can increase it. So eta is equal to 0.1. So that is called your learning rate. And then I have given the common weight vector. After that, you can update the weights. Right? So look at the algorithm here. So first what I have to do. As we have seen that we have to calculate the net output. We have to calculate the net output, right? See, I should know that what is my actual output is. Target output they have given, but I should know what is my actual output. To calculate your actual output, net output, first you summate the multiplication of weights and then inputs. This is called your network output. What is the network providing you the output? And after the network, once the value is coming out of the network, have you remembered yesterday we have applied an activation function, a wave kind of symbol, right? We have to apply the activation function over the input to stabilize it. Something called signal modulation. We'll be using the modulators to improve the signal attenuation, right? Like that. To improve our output, we used to apply our activation function, that is applying the sigmoid function on your net output. This is what your actual output is. So applying sigmoid function is nothing but whatever the value you are getting here, just do it 1 by 1 plus e power minus that value. So nowhere here mentioned about the formula. How do you apply sigmoid function on the net output is 1 divided by 1 plus e power minus x. That x is nothing but your net output. Then check. After that, calculate your delta Wi. Since this delta Wi value is useful for me to update the weights, and that updated weights has been provided to the next input. Clear? Any doubts till now?
No, ma'am.
Okay. So let me go for first step is calculating the net output. Later I can modulate it. Later I can apply the activation function over the output. Why I have transposed my weights. So don't do, importance is more for your x. So input you take it as it is, because whenever I'm doing matrix multiplication, I have to check the number of columns in my first matrix should be equivalent to the number of rows in my second matrix. I cannot take the weight matrix as such. If you see the previous screen, the weight matrix is your column matrix. See that? Weight matrix is your column matrix. I cannot multiply a column matrix with a column matrix. Here, the number of columns are 1. Here, the number of rows are 4, x1. You see? So what I have to do is I have to transpose the weight matrix. Then I can multiply that with x. Just transpose rows into columns and columns into rows.
Ma'am, few students are waiting.
They don't know the time.
I don't know, ma'am.
Yeah. So I have explained you why we have to transpose the matrices, because it's a matrix multiplication rule. So only transpose the weight vector, not the input vector. So transpose your weight vector, what is given, rows into columns and columns into rows, and then multiply that with the x1 input. It's very simple, 1 into 1, and then minus into minus plus 2 plus 0 plus This will be minus 0.5. Add it together, I think you are getting 2.5. So this is not actually our output, right? So we have to get output either 1 or minus 1. It is coming 2.5. So what I have to do? I have to apply the sigmoid function. Sigmoid function, if I apply, this value is 1 divided by 1 plus e power minus 2.5. You will get 1. You will get 1. Then update your weights to apply to the next input. Because you have next input, right? So please update your weights to apply for the next input because 3 inputs has been given to train your system. So how do I update? My update rule is, it is given it here. Wi will be updated with Wi plus delta Wi. So delta Wi value, how do you calculate? Your learning rate into target output minus actual output, what you got, into Xi. Right? So every value is given to you in the question. So first calculate delta Wi, then apply to add that with Wi. So delta Wi is learning rate into target output minus actual output into X. Your learning rate is 0.1, which is given in the question. The target output T1 for the first sample is minus 1 minus your actual output just before you have calculated in step 2 is 1. So minus 1 into X1. Xi, right? First training example, no, you're doing. The X1 value I have taken. So multiply the values with minus, this will become minus 0.2 into all these values. This is your delta W. Now to get the updated weight, what is your previous weight given in the question? Add that with delta W, what you have calculated right now. So you are getting a weight vector right now. So these are the weights for us to apply to the second input. To what? To apply it to the second input. So as such, so this is my second input X2, which is given in the question. The target output also given minus 1. Learning rate is common for the entire example. Again, what I have to do? First of all, I have to calculate my net output. Net output calculation is your input multiplication with weight. Since I cannot multiply these two columns because my weight vector first row, first matrix columns are not equivalent to the second matrix rows, what I have to do is, please transpose the weight vector. I have transposed it and then multiply that with X. So the resultant of this multiplication of weight vector and input vector is minus 1.6. But actually I have to get either minus 1 or 1, right? So for that, what I have to do? I have to apply the sigmoid function. Apply the sigmoid function on minus 1.6. How do you apply? 1 divided by 1 plus e power minus 1.6. So you will get minus 1. Okay, either minus 1 or 1 is okay. Now what I have to do is, now I need to update my weights to apply the next input. So updation of weight happens. First calculate delta W, then add it with your W. Since delta W is getting 0 value, your learning rate 0.1 into target output minus actual output is minus 1. I think it is getting 0. So what we have to do is, if this is getting 0, the entire value of delta W is 0. So then no change in the weights, right? I have to, how do you change the weights? Your actual weight plus delta W. Since delta W is 0, the weight is that weight itself. So no change in the weight. The same thing, then apply that with the third example. Third example. So this is given in the question. Target output given in the question. Weights, no updation with respect to the previous question. Previous sample. So take it as such. First calculate net output. Net output is transpose of your weight vector with X. Do it. I think you're getting minus 2.1. Since your net output should not be minus 2.1, it has to be either 1 or minus 1. Apply the activation function. After applying the activation function on the output you're getting -1. -1 is acceptable. 1 and -1s are acceptable. Then you have to update your weight vector. So first of all, you have to calculate delta W. So learning rate into target output minus actual output into input. If you do that, I think you're getting this is the value, and then add that with actual weight. So your weight updation is actual weight plus delta W, right? So these are your final updated weights. Is any doubt in perceptron training rule?
No, ma'am.
See, any algorithm which you have in your machine learning portion, definitely you will get a problem out of that. Means I cannot assure that all the algorithms will have the problems in the VTU question paper, but when you are studying an algorithm, just focus on, problem point of view also. We don't know whether they may ask you algorithm or the problem based on that. So you should know how to apply the algorithm on the data given to you. So this is your perceptron training rule. If you want, you can take a snapshot of this. So this is the perceptron training rule algorithm. So first we have to calculate the net output. If the net output is not 1 or -1, you have to apply the activation function called sigmoid function. Then update your weights with the formula given to you. Then apply the updated weights to the next input. So how many number of input vectors given to you, that many times you have to update your weight vector. Clear?